Okay, so now you should know what electrical charge is, electrical forces, electrical fields, electrical energy, and electrical voltages. So now we're going to talk about electrical materials, and you need to know the difference between a conductor and an insulator. So a conductor is going to conduct electricity, and an insulator is not. And so what we need is a kind of material that can conduct electrons very easily. So what would that be? Metals. So if you recall, in our previous lesson we talked about the atom, and we said that in metallic bonding in a metal, it has trillions and trillions of electrons that can jump from one atom to the next. And so in doing so, it can carry an electrical current. So examples of conductors are all going to be metals. So it could be gold, silver, aluminum, whatever metal that you want. So any kind of a metal that can conduct those electrons, those are going to make very good conductors. So one of the best conductors is going to be gold. But the problem is gold is very expensive. So copper is also a very good conductor of electricity, and copper is pretty cheap. So that's the reason why most wires are going to be made of copper. So then what is an insulator? Well, just about everything else. So if it's not a metal, it's going to be an insulator. So that could be glass, it could be wood, it could be plastic, it could be rubber. So all of these different kinds of materials are going to be insulators. So on the atomic level, what's going on? So do you remember when we talked about covalent bonding, like water, where the electrons were being shared by two atoms? Okay, so that the electrons are not free to jump from one molecule to the next. And so therefore, like in plastics and in glass, you have a lot of covalent bonds, and they do not conduct electricity. So they make good insulators. So for purposes of the exam, be able to give me an example of a conductor and be able to give me an example of an insulator, and then explain what's the difference between the two on the atomic level with what the electrons are doing. Now there are two other kinds of materials that are used in life, and that's going to be semiconductors and then superconductors. So the definition of a semiconductor is normally it's going to be an insulator. But at the right energy, so if you give a semiconductor the right amount of energy, it will become a conductor. And so I want you to watch this little video here. What is a semiconductor on YouTube? They are very important because you find semiconductors in all of the silicon chips in your calculators and in your computers. So that a semiconductor can act like a faucet. It can be used to control the flow of electricity. And so you have semiconductors in your calculators and stuff, which is controlling the flow of the electrons through that electronic device. All right, then what is a superconductor? So superconductors normally are going to be an insulator, so they do not conduct electricity. But below the right temperature, they become a conductor. Now, how cold? All right, so current current superconductors become superconductors at temperatures below negative 243 degrees Fahrenheit. So it has to get very, very, very cold before these materials will turn into a superconductor. Now notice I say it's a superconductor and not just an ordinary conductor, because in a wire, so if you've got a wire consists of atoms of, let's say, copper. And then let's say that you've got an electron that is flowing through the wire. As it does so, it's going to be bumping into these various atoms. And as it bumps into each atom, it loses a little bit of energy because the electron gives some of its energy to these atoms. The atoms start to vibrate, and therefore the wire starts to get hotter. We'll talk more about that later. But the wire will get hotter as electricity flows through it. Now with a superconductor, what happens is that you have pairs of electrons. And the electrons, instead of giving their energy to the atoms, they give their energy to each other. And it's kind of like two figure skaters, and they're pushing on each other, so that they're giving their energy to each other instead of to these atoms. So that means that it doesn't lose any energy. So that means this wire doesn't heat up if it's got if it's made of superconducting materials. Well, who cares? Well, let's imagine that you have a flashlight, okay? And you take your flashlight and you unscrew it, and inside the flashlight you got batteries. So I'm going to take a wire and I'm going to attach it to the positive end of one of the batteries, and I'm going to run it to Los Angeles, California from Springfield, Missouri in North America. And then I'm going to take another that wire in Los Angeles and attach it to the bulb, and then take another wire from the bulb, run it back to Missouri, attach it to the other end of the battery, turn on my flashlight, and in Los Angeles that light's going to come on. So that electricity would be able to be transmitted for extremely long distances without losing any energy with these superconducting things. But what's the problem? Well, you got to have temperatures that are really, really, really low. So currently they're not that practical for electrical transmissions. Another problem is they're brittle. So these superconductors are like pottery, and what we need to have is a wire, and wires need to be bendable. So that's another problem with superconductors. So I want you to watch this little video, see superconductors on YouTube. Okay, let's take another break, and when we come back, we're going to talk about some applications of electrostatics.